This is our second video about arrays, and in this one, we're going to talk about a couple of mixed things. First of all, we're going to talk about searching, how to search through an array to find something, okay? Then we'll talk about a simple way we can do a sort on the array, and we'll end with a little bit of a discussion of C strings, okay? So the first thing is search. Search is a very important thing in computer science. We're always searching for things, okay? And the search we're going to do today is called a sequential search. And it's the simplest search, but it also takes the longest. Okay, so maybe later in this class, but certainly when you take data structures, you'll get to some more complicated, but a lot quicker searches. Okay, so the idea behind a sequential search. So you see here, I've got an array. I'm in Excel just so I can show you what's happening. So here's our array that we have. Okay, whatever it's called. They are, whatever. Okay. So our basic idea for the sequential search, I'm going to start at position 0. Okay. So this is 0, 1, 2, 3, 4, 5, 6, 7 items here we have. Okay. So I start at position 0 and I say my search term is 6. Is AR sub 0 equal to 6? No. I move on. No, I don't move on that way. There we go. That way. Okay. I then move to the next one. Is AR1, which is 15, equal to 6? No. Okay. I move on to AR2, which is 58. Is that equal to 6? No. I then move on to AR3, okay, which is 6. Is that equal to 6? Yes, it is. Okay. And what I'm going to do, I'm going to return that 3. That's the index where we found it. Okay. Now, if we didn't find it, if I were looking for instead, let's say 16, okay, so then I would continue. Okay, I look here. Now I look there, and no, that's 6, not 16, so I didn't find it. Okay, not there, not there, not there. So when I get to the end, I have nothing to return, but the function is a int function. I have to return something. So by convention, we return a -1. So -1 means that it didn't find it. Okay. Any other number means that it found it and at the position it's found at. Okay. So this again assumes that we're looking for a type, that we're looking for the type that the array is. Okay. We're not tested for that, but that's the assumption there. Okay. So now let's take a look at some code. I've got some partial code here, and we'll go through and figure out the rest of it. Okay. So here we have the basics where we've got the sequential search, what this function is going to look like. So again, since we're using arrays, I'm going to make my constant int size equal to 10. That just happens to be the length of the array that I'm using. The sequential search is not going to matter because, and this is using what the book said, they're calling it list and list length. I would typically send along size or something else, but that's okay, it doesn't matter. So our int sequential search, it's going to return an integer. It's going to take a list, an array, okay, of ints. I put the constant keyword in here because a search shouldn't change your list. Okay, if so, something's wrong. Okay, so I'm sending along the list as a constant. I'm sending along the length of the list, and I'm sending along the search item. Okay, so the length of the list is always going to be an integer no matter what. But this type and this type have to be the same for this to make any sense. Okay, so that's just our prototype. We'll talk about the function in a minute. And then as far as what we've got here, I'm just going to go ahead and I'm hard coding my int list directly to have those elements. Okay. And then I'm going to have an integer for the search term, which I'm then just going to ask the user to enter the number they want to search for. Okay. I get that search term. Okay. And now I'm going to create an integer called position, which is going to catch the results of the sequential search. So I'm calling the sequential search function with the int list I've just created. The size is my constant int for the size of the array, and the search term that I've just typed in. Okay. So that's going to give me a number. Either it finds it, which is between 0 and size -1, or it gives me a -1. Okay. So I'm going to now I'm testing to say if it's not equal to -1, then say it was found at this position. Else must mean it is equal to -1, say that it's not found. Okay, so that's all pretty basic. Okay, so the next thing we have to do now then is to actually start typing in this function. Okay, so I've just copied this stuff down. Okay, and the idea again is we're going to loop through the array. We're going to look for the search term. We're going to stop when one of two things happens. We're going to stop when we're done. We've got through all the records. Okay, we've gone all the way to list length, or stop when we found the item. Okay, if not, we would have to keep searching, and it would be inefficient on a big list. And if you find more than one, this returns the first, not the last. Okay, so what we're going to do here, I'm going to set up some variables first. I'm going to set up an integer called location. I'm going to initialize equal to 0. Okay. And I'm going to set up a Boolean called found. Okay. I'm going to set it equal to false. Okay. So those are both set up. So I can now start my loop. Okay. So my loop is going to be while my location that I'm searching for is less than the list length. Okay. So that has to be true. I also want it to be the case that found is false or not found. Okay, so if the location is less than the list length, so I haven't gone through the list all the way yet, okay, and it hasn't been found yet, I'm going to enter the loop. Okay, so inside of the loop here, I'm going to start by saying if, what do I care about? Okay, if the list that I'm sending in at the location that I'm currently on, if that's equal to the search term, search item that we passed in, okay. If this is true, then we have success. I'm going to set found equal to true. Okay. That's all I have to worry about. We're done with that, right? That's good. If not, okay, so that didn't work out. I'm going to go ahead and increment my location. That's going to take it up one more and go on to the next item. Okay. That should then end the while. You can sometimes put in comments here. We're ending the while here. And that's going to go back and get the next item. Okay. We're going to keep doing that. Okay. And then for this last part here, we have to return something, right? And if we found something, okay, so we have our if found. If this is true, then we can just return our location. Straightforward. We have something to return. Okay. If not, our else here is going to be this value that we're going to say means that we didn't find it. Okay. So the else is going to be to return a -1. Okay. So we can go through this and see what's what. It's sometimes not a bad idea. I didn't on this one, but sometimes when I'm testing, I'll go ahead and print out the list or the array on the screen just so people know what we're doing. But let's say we're going to look for a 78 when I test this, and 78 should return a 0, 1, 2, 3. 78 should return a 3. If I type in a 99, it should return a -1. Okay. Let's try it and see. So let me go ahead and compile this. Let's get these ridiculous names so I can find them in my list of programs. Okay. Going to run it. And the number I'm searching for was 78. It's returned 78 found at index 3, which is correct. If I run it again, 99, 99 was not found. Okay. So that's the basics of the sequential search. The only problem is with the sequential search is that it's going to potentially, if it doesn't find it or it finds it the last item, however many items, if you have a list of 100 items and it doesn't find anything, it's going to do that comparison 100 times. So again, we'll get more efficient ways later, but this is a simple way for now. Okay. So the next thing we're going to talk about is how to sort our list. Okay. So sorting is something that comes around a lot. It's a very important topic in computer science. Okay. And while there are a couple of search algorithms, not all that many, the grand scheme of the world, but there are a few. What there really are a whole lot of are sorting algorithms. Okay. Sorting turns out to be a big deal. Okay. Because data is easier to search, it's easier to deal with when it's sorted. Okay. So the sort that I'm going to go through these examples here, is one of the simpler ones. Again, simple means that it's going to take a while. Okay. And it's called a selection sort. Okay. And this sort means basically that we're going to have to go through for every item in our list. Okay, we're going to have to go through and do something. Okay, so that's not the most efficient, but it is going to work relatively effectively. Okay, so this is how it starts. We're going to set up a counter. We're starting with I being equal to 0. Okay, it's going to go up to all the possible values. Actually, almost. It's going to go. We have 0, 1, 2, 3, 4. It's going to go up through 3 because at the end we're going to be fine. We'll tell you how that looks. Okay. So what we're going to do at 0, we're taking in the entire array. Okay, from 23 to 16. We're doing our smallest version of the King of the Hill. We're going to say, let's assume 23 is the biggest. And now I'm going to compare it against all the others. So I compare 23 against the 8 and see which one's the smallest. So 8 becomes the smallest. I compare 8 against 41. 8 still the smallest. I compare it against 30. 8 still the smallest. And here 8 is still the smallest. So I'll put the check here. This is the smallest. Okay. Since I know in the entire array 8 is the smallest value that we have, I'm going to go ahead and put that in position 0. And then I know that is sorted. So when I move down to here, and what I do, I swap. I'm swapping the 23 and the 8. Okay. And now I've put this in a darker blue here because I now know for certain 8 is sorted. Okay. Now we try again. We've got the 23, 41, 30, and 16. We're going to do again the King of the Hill algorithm. We're assuming 23 is the smallest. We're going to compare it against 41. It's still the smallest. Compare it against 30, still the smallest. Oh, when we get to 16, no, 16 is the smallest. Okay. But we've increased our I counter here to 1. So I needed to say that. Okay. So we now have 1 item sorted. So we're going to move the I to 1. Okay. So now we have that 16 is the smallest of what's left. Okay. So I'm going to swap the 16 and the 23. Okay. And now I know that the 8 is the smallest. The next is the 16. Okay. Then we're going to increase our I value to 2. We're going to do it again. We're going to do the King of the Hill algorithm on 41, 30, and 23. Okay. We assume 41 is the smallest. We're going to loop through the rest. We loop through 30. Now 30 is the smallest. Now 23 is the smallest. That's the smallest. We're going to swap out the 23 and the 41 and say that now we know the first 3 elements of our array are correct. Okay. So then we go to the last time, the third time, in this case, our last one, because if the first 4 elements of our array are sorted, the 5th one has to be, if that's all we have, is 5. Okay. So now I'm going to check the 30 against the 41. Okay. 30 is the smallest, no swapping necessary. And we've now sorted our array. Okay. And it took us 1 step for each length of the array, -1. Okay. So that's the basic thing we're going to do. I wanted you to see it visually as we're going along. Okay. So now let's look at some code, what the selection sort is going to look like. Okay. And again, I've got part of it listed out here to save some time. 6.2. So in this case, I will tell you, I've gone ahead and added a print array function just because when you're sorting, you could just say, yeah, we're sorted, but it's you really want to see that. Okay, so my print array function, it's a constant list, int list, because again, we're not going to change the list when we print it. And then I've got the int length being set to that function. I'm again using my constant int size equal to 10. Here's my list. Okay. The print array is pretty basic. I'm just going to loop through. Again, I'm setting the list and its length from I equals 0 to I less than the length, I plus plus. Print them all out on their own line. No, actually, I'm tabbing. Okay. That's it. Okay. Again, this doesn't violate my rules because the function only does printing. And then I put a new line character at the end. So that's pretty basic. That's not what we're dealing with in this one. Okay. So the other one we have is our selection sort, which is just going to take an array we're calling list and the length of that array. Okay. So then in my main, I'm going to create this random array, my random list of numbers, 10 of those. I'm then going to print out the original array, and then I'm going to print out the array after sorting. Okay, that's the basic idea. And I do that by calling in between the selection sort on the list. Okay. So again, just based on what I just said, what we're trying to do here, we're trying to put the smallest item in the array in position 0. And then of what's left, the smallest of what's left in position 1, and then position 2 until we're done. Okay, so that's basically what we're doing. Okay, so for this, I'm going to start by doing a couple of ints here for smallest index. Okay, I have a location, and we have a temp. The temp's going to be used when we go to swap things out. Okay, now I'm going to do a for here on int on my index is going to be equal to 0 as long as index is less than length minus 1. Again, the minus 1 is because when we've sorted 9 out of 10 items correctly, the 10th one has to be sorted. Okay. And then I'm going to do an index plus plus on that. Okay. So no matter what our size is, that's going to work for us. Okay. So inside of here, we're first going to figure out, okay, we want to, so the book calls this step A. We're going to find smallest item in remaining list. And this first time through, it's the whole list, but we don't know that for sure. Okay. So I'm going to set my smallest index. This is setting the king of the hill beginning point equal to whatever index we're on in our bigger loop. Okay. I'm now going to loop through the rest of what's left. Okay. So in this case, I'm going to say for location equals, I start at the index plus 1. Okay. Because I'm going to compare index to all the others. Okay. I'm going to go as long as location is less than the length. So I'm going to go all the way to the end. I'm going to do a location plus plus. Okay. So this is searching. The first time it's going to search the entire array, and then every time it will search one less as it puts things in order. Okay. So I'm now inside of here. I'm going to say if the list at location, okay, if this is less than the list at the smallest index, again, this is our king of the hill algorithm. Okay, we're going to set the smallest index to be equal to that location. Okay. So we're tracking through all of the remaining items to find the index of the smallest one. Okay. So that should get us through that. We're going to go all the way through. That gets us out of our for loop. Okay, and I'm going to go ahead and we're ending the inner for loop here because we have an inner and an outer. Okay. So at this point in the code, okay, we should have the index of the smallest item. Okay, so we want to do step B, which is swap smallest item to the first location we started with. So 0 the first time and then 1, then so forth. Okay. So that's what we're going to do. So at this point, we know of what's left. We know the smallest one. Okay. So I'm going to set my temp value here. It's going to be equal to list smallest index. Okay, so that's equal to our smallest item left. I'm then going to set the list smallest index equal to the list at the index position that we care about. Okay, first one to begin with, second and so forth. Okay, and we had to make sure that we kept the smallest index, because if not, it would have overwritten it. Okay, and then finally our list index, we're going to replace it with the temp that we just created. Okay, and then this one is going to end the outer for loop. Okay, and this one here is going to end selection sort. That ends our function. Okay, so again, this outer loop is going to take us through one at a time. It's going to start with 0 and go all the way through. So if we have 10 items, it's going to go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, and each time we're going to find the smallest value. The inner loop is going to go through and find the smallest value in those remaining items. It's going to swap it with the one we're looking for. Going to keep moving on. Okay. Take a look at this, see if it works, see if I typed it in correctly. So far, so good. In this case, we have our initial array is 2, 56, 34, 25, 73, 46, 89, 10, 5, 16. And then after we have 2, 5, 10, 16, 25, 34, 46, 56, 73, and 89. Okay, so two things have to be correct here. First off, it has to go in ascending order from smallest to largest. It does. Second off, we have to have all the same numbers, and all of them have to be there. You can't lose any along the way. Okay, so that works. That's our selection sort. Okay, so code this up yourself. Go through and make some example programs to make sure you understand how this is working. Okay, this one's a little weird. Okay. And then the last thing, as the book likes to do, kind of throws in something random. Okay. Look at it, not compile it. And this is the idea, and it's a little bit hard to read. Sorry about that. It's the idea of a C string. Okay. So C was a programming language, still is a programming language, but C was around before C++ was. And in C, there were no strings the way we normally do strings. So instead, we have these C strings. Okay. And what a C string is, different from the strings we've used so far, a C string is an array of characters. Okay, so it's not the same as a string. Okay, there are times it gets used, not a ton. So this is not the biggest deal of things that we're talking about. Okay, one thing about this array, or this array of characters, the C strings, which is different, the last item in the C string has to be the null character, which is a single quote \0 single quote. Okay. So for the most part, C strings act like arrays, because they're arrays of characters. Okay. So you can see in this first section here, I can declare my array or my C string, character name 16. That's fine. Okay. That would reserve space for 16 characters. But remember, only 15 of those can have something in them, because the last one has to be that null. Okay. We could also, as we've done with other arrays, go ahead and put the values in directly. Okay, so I could say char name 2 bracket 16 is equal to, and then I've got the word here, John, the characters, JOHN, new line character. Okay, so it's important this new line character has to be here. And I can't just write it together. I've got to write individual characters. Okay, the reason we don't use C strings much, because they're kind of a pain for that reason. Okay. Note that we can't do the following. So I can say char student name 20. That's fine. That's going to reserve 20 characters for the student name, 19 of which are usable. I can't say, so I'll comment that so you can see. I can't say student name is equal to whatever. Okay, can't do that. because arrays don't work that way, and this is an array. Okay, so a string you could do that, C string you can't. Okay, so it turns out that there are some functions that we can do with C strings. Okay, the basic idea, we have a string copy. You copy from S1 to S2. It comes a version with a limit and without. For security reasons, always use the limit version. There have been some hacks people have done in the past on C and C++ programs using the string copy and the string compare, where they give it more information than you expect. So you can put a limit on those, how many characters should be read. Okay, so a string copy or a string compare. Okay, if you want to use those, you have to include the C string library at the top, along with the other stuff, the IO stream, okay, to include C string. Okay. And again, we'll have some example problems to do probably with C strings, but they're not a big deal. We can do a CN like always. Okay, so once I've determined I have my character string, my C string called name that I did up earlier, I can do a CN right to it. That's fine, and I can C out it. No big deal at all. Okay. So again, to summarize today, it's the second of 3 videos on arrays. So the bigger things we talked about, a sequential search, we start at the beginning, we look at every item to see which one, see if it's there, okay? Which means if we have 1,000,000 records, we're gonna start with record 1, record 2, all the way to 1,000,000, okay? The second thing we talked about is sorting. There are a couple of different search algorithms. There are dozens of sorting algorithms that have different efficiencies or how long it takes them to sort things, okay? We did the selection sort. It's basic, but it's good enough for small things. Okay, with the selection sort, basically you're starting at position 1 in your array, index 0. You're finding the smallest element of the array. You're swapping it to position 0. Then you move to position 1 and take the rest of the list. Smallest one goes to position 1, and so forth until you get to the next to last item. And when you get the next to last item sorted, the last item has to be sorted. Okay. And then we ended just now with a brief discussion of the C strings, how they differ from strings, and did a brief example of that. Okay. So again, we're starting as we are with arrays in general. We're dealing with memory concepts. So this may be a little confusing. So if you have questions, make sure that you let me know.